In this talk, I'll explain in simple, non-mathematical English the secrets of understanding what relativity really is and how it really works. This is a revolutionary new way to understand relativity, and it also immediately explains the true underlying nature of mass and energy, and for the first time, why mass and energy can be converted into each other and conserved. It also gives us an entirely new understanding of the nature of space and space-time itself, and it also improves the standard curved space model of gravitation. And this model in turn shows us for the first time why the presence of mass actually curves space-time. And in addition, it gives us an entirely new insight into what's really going on inside black holes. So as you see, this isn't just another standard physics talk, but an entirely new understanding of mass, energy, space, and time, which all turn out to be different aspects of the same fundamental phenomenon. So let's get started with the first of the two very simple fundamental principles that underlie relativity. The first principle is that everything in the universe continually moves through space or time, or a combination of space and time, at the speed of light. This means that if something is standing still in space, then it's moving at the speed of light through time. And the internal clocks of photons of light stand still in time, and that's why light moves through space at the speed of light, because it has no intrinsic velocity through time. And everything else moves at some combination of velocities in space and time, and the faster it moves in space, the slower it moves in time. So in every case, the total velocity in space and time of everything in the universe is always equal to the speed of light. There are no exceptions. This is a core fundamental principle of reality itself that can't be violated. Now a quick note is in order. Since space and time are different dimensions of a four-dimensional universe at 90 degrees to each other, it's actually the vector velocities of space and time that equal the speed of light. That means the squares of the space and time velocities add up to the square of the speed of light. So keep this in mind. When we say velocity, we mean vector velocity. This single simple principle underlies special relativity and explains why clocks slow when they're moving through space. And it also explains why time passes, because we continually travel through time at the speed of light, and this is what we experience as the passage of time. Yes, we always continually travel forward in time at the speed of light because of this fundamental principle of relativity, except when we travel at high velocities in space, in which case our velocity in time slows and we age more slowly. Okay, this first fundamental principle explains special relativity, but we still need to understand general relativity, which is the effect of gravitation on time. The key here is the second simple fundamental principle of relativity, which is that mass and all forms of energy are all forms of spatial velocity. That's right, energy is just velocity in space, and that's all it is. Every form of energy, including mass, is just some form of spatial velocity. Now we already know that kinetic energy is just linear spatial velocity. Heat energy is just the aggregate kinetic energy spatial velocity of all the molecules in a material, and that electromagnetic energy is just spatial velocity in the form of electromagnetic waves in space. Now it's only because all forms of energy are all forms of spatial velocity that energy can be conserved. For something to be conserved, it must quite obviously be different forms of the same underlying thing. Okay, but how does mass fit in? What kind of spatial velocity could mass be? Since masses can be either at rest or in motion, there's only one possibility. Mass has to be ultrafine, in-place vibrations in space itself. Specifically, a mass is a field of ultrafine standing vibrations in space itself. This simple but profound insight immediately explains the gravitational effects of mass, the effect of gravitation on time in general relativity, and why mass and energy are conserved. Mass and energy are conserved because they are different forms of spatial velocity. So the conservation of mass to an equivalent amount of energy is simply the conversion of an equivalent amount of ultrafine vibrational velocity to either linear or waveform velocity in space. Okay. So we now have the two simple fundamental principles that explain essentially all of relativity. One, everything in the universe is continually moving through combined space and time at the speed of light. Two, all forms of energy, including mass, are forms of spatial velocity, and masses are fields of intrinsic ultrafine vibrations in space itself. So this explains why time slows in a gravitational field. It slows because a gravitational field is a field of intrinsic spatial velocity, and time must slow within the field so that the total space and time velocity of anything in the field continues to equal the speed of light. Now this new model of masses as fields of ultrafine spatial vibrations also explains why gravitational fields attract. The vibrations of gravitational fields get weaker further from their centers of mass. This sets up a velocity gradient in the field with more intrinsic velocity closer to the center. This creates velocity vectors pointing towards the center that the inertial motion of objects in the field tend to follow. This is why gravitational fields attract toward their centers of mass. We stand on the surface of the Earth because there is a greater amount of intrinsic spatial velocity in that direction. In effect, this model of masses as fields of intrinsic vibrational velocity in space explains why mass curves space, something missing from traditional discussions of general relativity, which just state that mass curves space without telling us why it does. In fact, this new model suggests an improvement to the usual curved space-time model of relativity. We can replace the old curved space model with a completely equivalent but much easier to understand model of densified space-time. In this new model, space-time is still four-dimensional, but it's Euclidean and flat, which is the way we actually see it is. Instead of gravitational curvatures, there are now fields of vibrational densification due to the presence of mass. The models are completely equivalent and all the equations of relativity still work just fine. We just take all the curvatures and compress them all along themselves until space becomes flat again, and then we set these very fine crumples along the curvatures into vibrational motion. The result is that space is now much easier to comprehend, and it's enormously easier to understand how relativity works than before. But there's more, much more, because this new model reveals the fundamental equivalence of space and time with mass and energy. Because if mass and energy are just forms of spatial velocity, and total space-time velocity always equals the speed of light, then mass plus energy plus time always equals the speed of light. Mass and energy are just forms of space, and space itself is just a giant universal field of energy. Because these two fundamental principles are essentially talking about the same thing, they can be combined into one single, even more fundamental principle that underlies all the four fundamental aspects of the observable universe. Mass and energy are forms of spatial velocity, and spatial plus time velocity always equals the speed of light. So we can now say the total amount of mass, energy, and velocity and time at every point in the universe is always equal to the speed of light. This amazingly simple single principle essentially tells us everything we need to know to understand how mass, time, space, energy, gravitation, and relativity work. It's truly amazing and truly profound. So the entire universe itself now consists of a single fabric of intrinsic speed of light velocity. The total space-time velocity always equals the speed of light at every point in the entire universe. This velocity can take the form of either velocity in time or velocity in space. And whatever it takes the form of velocity in space, that velocity manifests as some sort of energy or mass. So imagine a universe originally full of empty space. At every point in this universe, time passes at the speed of light unless there's some mass or energy present. Since every mass or energy consists of velocity in space, the velocity in time always slows, so the vector velocities in time and space still always sum to the speed of light. Now note that a velocity in space can only be with respect to space. So there must be something to move with respect to space, inside space, for there to be any velocity in space at all. The things that can move in space with respect to it are called elementary particles, and of course they compose all the structures in the universe. The only way things can have spatial velocity and move with respect to space is for little pieces of space to crystallize out into what we call elementary particles. Only if particles detach from the fabric of space can they move with respect to the space from which they detached. So whenever there's some form of spatial velocity, it's always because of the presence of some form of particle that carries the mass or energy of that spatial velocity. So we see the universe as a profoundly beautiful and simple system when reduced to its essential components. Imagine completely empty, original fabric of space through which time passes at the speed of light at every point. Then particles crystallize out of this fabric and separate from it. Because the particles are like little pieces of the space-time fabric, they can now move with respect to it, but they still obey its fundamental principles. Only because particles move with respect to space itself can they have spatial velocity, and this is the only way movement and velocity in space can exist. And the spatial velocity that exists is always some form of mass or energy. That's what particles are. They are a means the universe devises to create velocity with respect to itself. Particles are a means to create mass and energy in the universe so that structures can exist and things can happen. Without particles, this wouldn't be possible. The total velocity at every point in the four-dimensional fabric must still always equal the speed of light. So whenever there's some velocity in space associated with the existence of a particle, the velocity in time slows to keep the total velocity equal to the speed of light. In this way, the total space and time velocity of every point in space and every particle in space is always kept equal to the speed of light. And if particles move through intense gravitational fields, their velocity through space slows, as it does, for example, as they fall into a black hole. In this way, the total linear velocity in space plus the intrinsic velocity of the field never exceeds the speed of light. This simple fundamental principle of the velocity of light applies to the entire universe and to everything in it. It's truly amazing, truly profound and beautiful. Now, what we call empty space actually consists of the quantum vacuum, and virtual particles are continually popping in and out of existence everywhere within the quantum vacuum throughout the entire universe. As a result, the so-called empty space of the quantum vacuum is actually a universal field of energy called the zero-point energy. The average spatial velocity of this field is minuscule, but it is a field of energy that fills the entire universe. Within this universal field of zero-point energy, the fields of energy of the masses and charges of all the actualized particles add additional areas of intrinsic spatial velocity density to the field of the zero-point energy. So the entire universe becomes a single field of various amounts of spatial velocity, and at every point in this field, the amount of spatial velocity reduces the velocity of time, so that the total velocity in both time and space always remains equal to the speed of light at every point in space. So the entire universe consists of velocity at the speed of light or in one form or another. And all this leads to all sorts of other amazing insights that will be explored in upcoming Deep Reality talks. Stay tuned.